Hello, scientists. Today, we are going to finish up our study of materials, and we will be moving on next time to motion. So to finish up our study of materials, we're going to create a structure to keep sunlight off a cup of water. Our focus question today is, what happens to water in sunshine and shade? And how can we design a structure that keeps water cool in the sunshine? So to do that, I have 2 cups of hot water and 2 cups of cold water, ice water. What do you think the temperature will be? Let's put the thermometer in the hot water and see what happens. It's going up. Do you see the red line going up, up, up? It looks like it has hit about 116 degrees. That's what it looks like. Okay, we're going to take it out of the hot water and put it in the ice water and see what happens. Look at it go down. Whoa. It's going right down. It looks like it stopped moving now. It looks like it's about 44 degrees, this water. 44 degrees, and this was about 116 degrees. Well, today is a nice sunny day. It's not a warm day, but it's a nice sunny day. And I want you to think about what you think would happen to these cups if I put them in the sun or if I put them in the shade. We're going to see what happens when a cup of water is put in the sun versus a cup of water put in the shade. We're going to take one of our hot water cups and one of our cold water cups and put it in the sun, and take the other hot water and cold water and put it in the shade. Okay, here I've put my 2 cups, one warm and one cold, in the sun, and I've put these 2 cups in the shade. We will come back in 15 minutes to take the temperature of the cups that were in the sun versus the temperature of the cups that were in the shade and see what happens. Okay, it's 15 minutes later, and we're going to take the temperature. I don't expect that this is going to go up, because it is not a warm day today. But we'll see if there's a difference between hot water in the sun and hot water in the shade. It appears that our hot water in the sun is about 90 degrees. And our cold water in the sun looks like it's about 44 degrees. Let's see what our hot water in the shade is going to be. The hot water in the shade is about 88 degrees, maybe 89 degrees. Cold water in the shade, and again, this is after 15 minutes. It looks like our cold water is about 40 degrees. We're going to set the timer for 45 minutes. We did 15 minutes. We'll check in again in about half an hour. Okay, it's been 45 minutes since I put the cups of water outside. What do you notice right away? Do you see that some of the ice has melted? The sun had some of the ice melt? Well, let's take our temperature again of the hot water. Now remember, it's not a hot day, so I do expect the water to have cooled. We're looking at the difference between when the water's in the sun and the water is in the shade. So this water looks like it's about 70 degrees, the hot water. And let's see what the cold water. The cold water with the ice in the sun looks like it is still about, it looks like it's about 48 degrees. 48 degrees. Let's look how different it is in the shade. Well, the first thing I notice is that there's far more ice in the shade. Let's do our hot water. Our hot water is about 63 degrees. Let's see what our cold water is. Our cold water in the shade is about 40 degrees. Let's compare the data. Temperatures of hot and cold water. The beginning temperature of the hot water was 116 degrees. So after 15 minutes in the sun, again, I said it was not a hot day. It went down to 90 degrees. And then after 45 minutes in the sun, it went down to 70 degrees. In the shade, it went from 116 degrees down to 88. So do you see how it cooled faster in the shade? It went from, in the sun, it was 90. In the shade, it was 88. After 45 minutes, take a look. See the difference here is only 2 degrees, 90 to 88. But here, from 70 degrees to 63 degrees in the shade, it is a 7-degree difference. So do you see how the water can't stay as hot in the shade? Let's look at our cold water. What do we want to keep cold? We started out with 44 degrees. That was the, and then after 15 minutes in the sun, it was still 44 degrees. But in the shade, it actually got cooler. It got colder. It went down to 40 degrees. And it actually, even after 45 minutes, it stayed at 40 degrees in the shade. That must mean that that was pretty much what our air temperature is today. It's not going to go any colder because that's about what the air temperature is. But look, in the sun, do you see that we kept our ice water at 44 degrees, but then in the sun, after 45 minutes, the sun raised the temperature of the cold water to 48 degrees. We weren't able to keep our water as cold in the sun. And do you think if we left it there even longer, it would warm up even more? Well, that, my friends, is what we are going to try to do today. The project we're going to do to tie up everything we've learned about materials, wood, paper, fabric. We're going to tie it up by making a structure to keep water cool in the sun. You see that the shade helps to keep the water cooler. We've done that work using the sun and the shade, and you can see how we can keep water much cooler in the shade than the sun. But let's say we didn't have any shade. Let's say there was no shade. You were out on the beach in the sun. How could you keep a drink cool? Your challenge today is to build a structure out of materials. Wood, paper, or fabric. You can use what you have at home. You can make a structure to try to keep water cool. Let me show you what I mean. Our starting temperature is 45 degrees. We are going to pretend that we want to keep our drink cool, but there is no shade. How can we keep our drink cool in the sun? Your challenge is to create a structure that will keep your drink cool. All right. I have 1 cup that I covered with nothing. This is our control. We'll see if we leave it not covered at all, how it works. This one I covered with my fabric napkin. And it drapes over the whole thing and kind of covers it. This one I covered with a piece of wood. It's a wooden cutting board. And this one I covered with a piece of paper. Now I'm afraid it's gonna fly off, so I'm going to also put my thermometer on top to keep it from flying off. We're going to leave these cups for 1 hour. And I will come out and see which cup of water is the coolest. What do you think will happen? Which structure will keep the water the coolest? Let's find out. Okay, scientists, it's been over an hour. The unfortunate part about this is that we don't have sun anymore and we have a lot of wind. So in our test cup, which had no covering, in our test cup, the water is 56 degrees. Let's see if it's any different in the cup with the paper. It is not. Let's see if it's any different in the cup with the napkin. It is not. Let's look up. The cup with the wood, look at this. There's still some ice cubes in. Let's look. Oh, the temperature's moving down. Look at this. The wood, the temperature is 46 degrees. What can we say was the best way to keep our water cool? What structure worked the best? It was that heavy wood which kept the water shaded. Are you able to make a structure that keeps your water shaded in the sun? Please make a structure that will keep your water shaded in the sun. And take a picture of it and send it to me. Okay, scientists, so now you're going to take investigation 3.6. The focus question is, what happens to water in sunshine and shade? How can we design a structure to keep water cool in sunshine? You can glue the piece of paper that shows what the temperatures were when I did the experiment in the sunshine and the shade. You can cut out the paper and glue it onto here somewhere, and you can write what you did for your structure. And if you want to add a picture, if you want to print out a picture of what you did for your structure, go ahead. But I would love to see, please send me a picture of the structure you made for your experiment. And then turn this over. You're going to put the line of glue on the top, flip it sideways, glue it into your science notebook so that you can fold it. That is what your investigation is today. Have a great day, scientists.